Why is division by 0 undefined? We'll use the distributive property of the real numbers to show why. So the formal statement is for every number x that's a real number, 0 times that number is equal to 0. We can write this. So 0x is equal to, well, this 0 plus 0 times x, because I can use the distributive property and 0 plus itself is just 0. But the right hand side is then equal to 0x plus 0x. But then I can cancel these two, and I just get that 0 is equal to 0x. Since x was arbitrary, this holds for every real number. So now we know that 0 times anything is 0. Now let's see what would happen if there was, in fact, a number, let's call it 0 to the negative 1 to mean 0 inverse, such that it would be the multiplicative inverse of 0. What that means is that 0 inverse times 0 would have to equal 1. But this can only hold true if 0 is equal to 1. Because unless 0 is equal to 1, this is just 0 times something, which is just 0, which would imply that 0 equals 1, which can only hold in what's called the trivial ring. Since 0 is not equal to 1 in the real numbers, the original statement is false, so there is no 0 inverse, and that implies that since there is no multiplicative inverse, division by 0 is undefined in the real numbers.